In example 2, we have a negative exponent, so let's do pretty much the same thing just like we did the previous problem. Notice since it's a negative exponent, it's just going to be kind of the backwards of what we did before. So I'm going to do x, and I'll do 5 to the negative x power. So I'll go negative 3, negative 2, negative 1, 0, 1, 2, and 3. And once again, I'll start with 0 because anything to the 0 power is 1. And then if I replace x with negative 1, so the opposite of negative 1 is 1, so it'll be 5. 5 squared is 25. Yeah, it didn't look out. That didn't work very nice. Make this a little bigger. And right, a little thinner too. Let's try that. So 5 squared is 25. 5 cubed is 125. And then if I do 5 to the negative 1 would be 1/5. 5 to the negative 2 would be 1 over 25. And 5 to the negative 3 would be 1 over 125. So if I graph those, it's kind of backwards. So as I go towards negative, it's going to increase. Whoa, that's terrible. Let me redo that. Okay. So I know my graph is going to be going up. Wow, I still can't. I didn't draw that very well. There we go. There, it's more like it. That's what I want to have. Okay, my domain, just like it was before, is going to go from negative infinity to positive infinity. My range, just like before, is going to go from 0 to positive infinity. My intercept, I only have my y-intercept is at 0. Don't have an x-intercept. 0 and 1. My end behavior, as x approaches negative infinity, notice f of x is going to approach positive infinity. As x approaches positive infinity, f of x is going to approach 0. It's going to get closer to 0. It's always decreasing because when I pick a point, or 2 points, if I pick a point to the right of it, it's going to be down further, isn't it? And instead of looking at the sketch, we can look at it on Desmo, so you can see it kind of nice here. Here, notice all my points, they're getting smaller and smaller and getting closer and closer to 0. And there we have it. So if we can generalize this, when we look at our graph, if I have a growth factor, if my factor of b is bigger than 1, that's called exponential growth. It's going to be rising to the right. If b is less than 1, it's going to be falling. In both cases, notice my domain goes from negative infinity to positive infinity. My range is 0 to infinity. Both increasing or decreasing have a y-intercept of 1. You don't have an x-intercept on either case. We don't have any extrema. My asymptote is towards the positive x-axis, and my asymptote is towards the x-axis. I don't know why I said positive, just towards the x-axis. And then my end behavior is just backwards from each other. If it's growing, as x approaches negative infinity, f of x approaches 0. And as x approaches positive infinity, f of x approaches positive infinity. And like I said, it's just backwards for decay. And it's always continuous.